Hi guys. Today we're going to pick up with chapter 5, perpendicular and angle bisectors. This is the first section of the chapter. So our learning target for the day is I can use perpendicular and angle bisectors to solve problems. All right, so a bisector, we're going to talk about what perpendicular means, then we're going to talk about what equidistant means. A bisector is a line that cuts a segment in half. So when it cuts a segment in half, in order to relate it to what we did semester, a line that cuts a segment in half, it's going to it passes through the midpoint. So if I have a segment here, we'll call this segment A, B. And this is M, stands for the midpoint. I'm going to show that it's the midpoint by putting my two congruent signs here. Okay, if that's the midpoint, a bisector is a line that goes through there. Now, a bisector can go through that line in any type of angle. Okay, we could go through this way, we could go straight up and down, this way, any angle as long as it's splitting it in half, passing through that midpoint. Now, perpendicular, this should be a familiar word, is something that intersects, so we have a line that intersects at 90 degrees. Okay, now we have a very specific way to show that. We're going to hit 90. Okay, this little square there will tell us. We don't have to have the numbers 90, we just have to have that square. Now, equidistant. This word basically gives its meaning in the way that it's spelled. It is the same distance between two points. Okay, it's the same distance between 2 points. If this is equidistant, okay, they have the same amount there. Now, the main event here, a perpendicular bisector. Perpendicular bisector, we're taking these two words and we're putting them together. Okay, we know that a perpendicular bisector, and we're going to call that AB for now. So AB is a perpendicular bisector. Okay, AB is a perpendicular bisector. So I'm going to draw a little figure here. We have the segment CD. Sorry, there's a dip in my table here. Okay, if AB is a perpendicular bisector, we have the line A, B. All right. Since it's perpendicular, it's crossing through CD at 90 degrees, but it's also bisecting it, so it's crossing through at the midpoint. Perpendicular, straight up and down, passes through CD at 90 degrees, cuts it in half, which is different from this bisector up here. It cut it in half, but it went in at a different angle. Okay, so AB is a perpendicular bisector. It did two things. It cuts CD in half, and it also intersects at 90 degrees. Okay, now here's the new information. Here's what we're learning and going to work with this chapter. Since B here, okay, is on the perpendicular bisector, I can form a triangle by connecting it to the 2 points. Okay, so any point on AB is the same distance to C and D. So in this case, this BC is going to be congruent to BD. Or I could put another point here, E. As long as I place it on the perpendicular bisector, the segment ED is going to be congruent to EC. All right. So it is creating, okay, when we connect these congruent triangles, and we're going to use all this information to solve different pieces. So we're going to apply the perpendicular bisector theorem. What is the value of AD? So AC is a perpendicular bisector because it hits at a 90-degree angle. And I look here, CB is 11 and CD is 11. They are congruent. That's how I know it's a perpendicular bisector. Well, we just learned that any point on the perpendicular bisector is going to be the same distance, equidistant, to the endpoints of the segment. So therefore, I can say that this is congruent to this here. So to solve for x, I can set up the equation 6x minus 10 is equal to 3x plus 2. And now we solve. X is equal to 4. So how do I use that to find AD? Well, I plug it in. AD is equal to 3 times 4 plus 2. 12 plus 2 equals 14. All right, go ahead and try this. Try it one on your own. So now this time, I don't know that this is a perpendicular bisector, except I can see that Z is equidistant to X and Y, so therefore these pieces have to be congruent. So I can set up the equation 2n plus 7 equals 5n minus 2. All right. What is the length of OL? OL is right here. Okay. OL, we see lots of things happening here. Okay. We know, OL is right from here to here. So KJ is congruent to KL. This is hitting at 90 degrees. So therefore, I can say that NL is equal to 14 because it's the same as this one here. Well, now we have the same scenario happening. We cover this up here. This is congruent to this, so these are going to be congruent. Well, if NL is 14, then we can cut it in half to find that as 7. So that is perpendicular bisectors. Angle bisector, okay, so we're still cutting something in half. It's a line that cuts something in half. So I'm going to start out with the angle ABC. Okay, I'm going to draw an angle bisector. So I'm drawing a line that is cutting this angle in half. So the angle bisector is BD. So it's actually not a line, it's going to be a ray because it starts at this vertex here. BD is an angle bisector. All right, so it cuts angle ABC in half. Now to show that it cuts in half, I'm going to put my little arc marks here. So we know that those two angles are congruent. If I take one of my points on the angle bisector and I hit the sides at 90 degrees and I hit this side at 90 degrees, I am able to say that this is congruent to this. So any point on an angle bisector, if it cuts to the angle's rays at 90 degrees, it's going to be congruent to the other. So I can say that angle ABD, so if angle ABD is congruent to angle CBD, then I can say that AD is congruent to DC. So let's apply this here. What is the value of KL? They want me to find this piece here. Well, looking, we have the angle KJM. It's cut in half, so JL, because we start at the vertex. JL is an angle bisector. So since that's an angle bisector, I know that LK is equal to LM because it's hitting the rays at 90 degrees. So I can take 2x plus 3, set that equal to 4x minus 11. When I solve, I get x is equal to 7. So KL is equal to 2 times 7 plus 3, 14 plus 3, 17. KL equals 17. Go ahead and try it on your own by pausing the video. All right, so we know they want us to find IGJ. IGJ. Here's what I know. I know HI is 7. I know IJ is 7. So since these are congruent, I know that G, they didn't give us, or what is it, GI is an angle bisector. I know that HGI is 25. So what is IGJ? Well, we found out that these are congruent, so angle IGJ is also 25 degrees. This time, they want us to find IJ here. So I'm going to redraw this. G, H, J, and an I in the middle. Okay, these hit here at 90 degrees. So now HGJ, this entire thing, is 57 degrees. IGJ is 28.5. And HI is 12.2. What is the value of IJ? Okay, well, they don't show us anything as an angle bisector directly. What they tell us is that this is 57 and this is 28.5. Okay, if I take 57 and I subtract 28.5, I'm going to get 28.5. So this is 28.5, which proves that this is an angle bisector, which means if HI equals 12.12, then IJ equals 12.2, excuse me. And that is it. Okay, that is it for 5.1. You have a Go formative to work on. Please let me know if you have any questions.